Okay, in an earlier lesson, we looked at solving systems of two equations in two variables. And so what we want to look at today is how to solve a system of three equations and three variables. However many variables you have determines the number of equations that you have to have. So the first thing we're going to do is to show that an ordered triple is a solution. So let's say we have the ordered triple, -1, -4, and 5. And we want to see, is this a solution for the system x minus 2y plus 3z equals 22, 2x minus 3y minus z equals 5, and 3x plus y minus 5z equals -32. So we want to know, is this ordered triple a solution for these? Well, for it to be a solution, what it has to do is to make all three equations true. So we're going to go through and we're going to substitute in. So we would have -1 minus 2 times -4 plus 3 times 5. Well, if we work that out, that's equal to -1 plus 8 plus 15, which would be 22. So it does make that equation true. Well, then we have to try the next one. 2 times -1 minus 3 times -4 minus 5. Well, that would give us -2 plus 12 minus 5, which would be 5. So it makes that one true. And then the last one, 3 times -1 plus -4 minus 5 times 5. Well, that gives us -3 minus 4 minus 25, which is -32. So it makes that equation true. So since it makes all three of the equations true, then this would be a solution. So yes, it is a solution. But it has to make all three. Just making two true doesn't mean that it is a solution. Now what we want to do is look, okay, how do we come up with that ordered triple given our system of equations? Well, back with two equations and two variables, we looked at two methods, substitution and the addition method. When we get to three equations and three variables, we're just going to use the addition method. So if we have our system, x plus 4y minus z equals 20, 3x plus 2y plus z equals 8, and 2x minus 3y plus z, 2z equals -16. Well, one thing you always want to do when you're solving systems of equations is double check that you wrote it down correctly. Because a lot of times the mistakes are not in the computation or in the solving, but in the writing it down. Okay, now what we do is we have three equations and three variables. We know how to solve two equations and two variables. So what we have to do is to take our equations two at a time and eliminate a variable. It's very important whichever variable you start to eliminate, then that's the one that you have to stick with. So if we took these, and we're going to look at our variables, and to eliminate them, remember, you need opposite coefficients. So we're wanting to do is look at these and see how easy it would be to get opposite coefficients. Well, here we could make this one -3 and +3. We can make it -2 and +2. So that would be a possibility. If we did the y's, we can multiply this middle equation by -2. Adding it to this one then would give us 0, because we'd have -4 and +4. But for this one, we'd have to multiply both equations. Maybe make this one +6 and this one -6. If we go to the last one, our z's are already opposites. That would be really easy. We have a 2z. We can multiply this top one by 2. So it looks to me like the easiest variable to eliminate would be the z. Now, once you decide, then you want to stick with that variable and not go through and change it. So we're going to eliminate the z. Okay, so what we're going to do is take our equations two at a time and eliminate the z. So I'm going to take my first two equations, and they're already opposite coefficients, so I'm just going to simply add them together. So x plus 4y minus z equals 20. 3x plus 2y plus z equals 8. So if we add these together, we get 4x plus 6y, my z's drop out, equals 28. Now I have an equation with just two variables. Well, if I have two variables, I need two equations. So what I have to do is take this equation that I haven't used. I've used the first two. I have to take this one and one of these two and eliminate the z. Well, it's a positive 2z. I'm going to take this top equation and multiply it by 2, and then I would have a negative 2z. So I would have 2x plus 8y minus 2z equals 20. 2x minus 3y plus 2z equals -16. That gives me 4x plus 5y, my z's drop out, equals 4. Except I didn't do something right here. I made a mistake. I multiplied my 2, my y, and my z by 2, but I didn't multiply my last number by 2. You have to multiply your whole equation by that number. And that's a very common mistake to make, but it's a mistake we want to make sure we don't make. So that's supposed to be a 40, and so this would be 24. So now I have two equations with two variables. So what I'm going to do is take those and eliminate a variable. Well, it looks like the x would be the easiest. Right now they're the same, so if we took one of them and multiplied by -1, I'm going to take this second one, multiply it through by -1, and I'm going to be careful on this one to multiply that constant by -1 also. So I have -4x minus 5y equals -24. Now my x's drop out, so 6y minus 5y would be y equals 4. 28 minus 24. Now I have it solved for y. So what I have to do is substitute it back in. Well, I need to substitute it back into one of these equations with two variables so that I can solve for the other one. I'm just going to take this first one. So 4x plus 6 times 4 equals 28. So 4x plus 24 equals 28. Subtracting 24, I get 4x equals 4. Dividing by 4, I get x equals 1. So now I know x, I know y, so what I've got to do is go back to one of my original equations that has three variables, substitute in x and y, and solve for z. So I'm just going to take that top one. So that would be 1 plus 4 times y, which is 4, minus z equals 20. So 1 plus 16 minus z equals 20. 17 minus z equals 20. So subtracting 17 Negative z equals 3, so positive z equals negative 3. So I now have my ordered triple of 1, 4, negative 3. We want to put them in alphabetical order. So this is the ordered triple that will make all of these true. To check it, you would go back and substitute it back in. So that's your idea behind solving a system of equation when you have three variables, is you've got to take two equations at a time, eliminate a variable, and then take the third equation, eliminate the same variable. You don't want to get sidetracked and start trying to eliminate different ones. You have to eliminate the same variable in all of them so that you end up with two equations with the same two variables. All right, let's look at another problem. All right, let's look at this problem, and we'll just go through the steps one more time. What we're wanting to do is to decide which variable we're going to eliminate. That's always the first step. Well, to do that, I'll look at all of my coefficients. I have 1, 3, 2. That wouldn't be too hard. I can make this negative 3, negative 2, and add it. For the y, I have negative y, positive y, 4. So that would be easy. These are already opposites, and then just multiply 1 by 4. I've got 3, 2, and 1, and so that would be the same as the first. So I would pick this middle column. I would pick the y to eliminate. Okay, I'm going to take my first two since I already have opposite coefficients. Adding those, we get 4x. The y's drop out. Plus 2z equals 6. Not 2z. Why? Just z. 3 minus 2 is 1. So plus z equals 6. Now we want to take this third equation. We have to take the third equation with one of these two and eliminate the y. So I'm going to use my top one and multiply it by 4. That would give me 4x minus 4y plus 12z equals 32. Then 2x plus 4y plus z equals 0. Adding these, we get 6x, the y's drop out, plus 13z equals 32. Now we have two equations and two variables. So we can choose to either eliminate the x's, and then we'll have to multiply both equations. We can make them both 12, or eliminate the z's, in which case we just have to multiply this equation by negative 13. So that's what I'm going to do. Negative 13 times 4 is negative 52x, negative 13z, and 6 times negative 13 would be negative 78. Then 6x plus 13z equals 32. Okay, adding these, I get negative 46x. My z's drop out, and negative 78 plus 32 is negative 46. So now I can divide both sides by negative 46, and I get that x equals 1. Okay, I'm going to take that value for x and plug it back into one of these two equations and solve for z. I'm going to use that first one. So 4 times 1 plus z equals 6. So we've got 4 plus z equals 6. Subtracting 4, z equals 2. And then I'll take that x and z and plug it back into any of these and solve for the y. I'm going to plug it into this middle one. So 3 times x plus y minus 2 times z equals negative 2. Well, 3 plus y minus 4 is negative 2. Y minus 1 is negative 2. Adding 1 to both sides, y is negative 1. So our ordered triple would be 1, negative 1, 2. Now, you go through these in a very orderly manner. And when you do, it's not difficult. It's easy to make little mistakes, as you've seen me do, multiplication or addition. And so you just have to be careful on that. But knowing what to do next is not difficult. You pick a variable to eliminate, and you use two equations, eliminate it, then use your third equation and one of those other two and eliminate the same variable. Gives you two equations with two variables. You take those, eliminate a variable. Then you start solving and substituting. Now sometimes when we do this, we may have a system where one of our variables already has just two variables. So we have this system here, but this top equations only has a y and a z. So what I would do then is I would take these other two equations and eliminate the x. Since the x is already eliminated in the first one, then we'll go ahead and eliminate it in the other two. There's not a, if we eliminated the z, then we'd have to go through and eliminate it in both sets. So this way, part of our work is already done for us. So let's multiply this top equation by -2. So we would have -2x minus 4y minus 2z equals -34. Then 2x minus 3y plus 2z equals -1. So we get 0 here. We have -7y. Oh, our z's dropped out also. Now sometimes that happens, and it's very nice when it does. But you don't really plan for that. You still go along with your plan. We were missing our x here, so we took these two to eliminate the x. When we did, we eliminated the z also. And that's just something that's very nice when it happens. And so we have, this is a -35. Now what we have is an equation with one variable, so we can solve it. So dividing both sides by -7, we get y equals 5. Well, we have an equation with just two variables that we can substitute that into. So we have 2 times 5 minus z equals 7. So 10 minus z equals 7. Subtracting 10, -z equals -3. So z equals 3. And then we can take that value and substitute into one of these equations with three variables. So I'll just take the first one, the x, plus 2y plus z equals 17. So x plus 10 plus 3 equals 17. X plus 13 equals 17. X equals 4. So our ordered triple here would be 4, 5, 3. That's the ordered triple that will make all three of those equations true at the same time. Okay, it's also true that sometimes you may have ones where more than one equation is missing. And at that case, you just pick whichever one you want to eliminate. It doesn't matter. We can eliminate the x's, the y's, the z's. They're all going to be just as simple. So let's just go through and eliminate the x's. To do that, we're going to have to multiply one of our equations by -1. So we have x plus y equals 4. Negative x plus z, I didn't really leave some space up there, equals negative x minus z. Let me just go through and leave a little bit of more space with this. We've got x plus y equals 4. Negative x minus z equals -4. So our x's drop out, and we have y minus z equals 0. Now we have an equation with a y and a z. Up here we have an equation with a y and a z. So we can eliminate, it looks like the z would be the easiest. So y minus z equals 0, y plus z equals 4. Adding, we get 2y, the z's drop out, equals 4, so y equals 2. We can substitute that in and solve for z, so 2 minus z equals 0. Adding z to both sides, z equals 2. And we could go back to the top equation and solve for x. X plus 2 equals 4, so x equals 2. So our ordered triple is 2, 2, 2. So we do have a system for solving when we have 3 equations and 3 variables. The other thing that we want to look at is how we take information and come up with a system of equations. Sometimes we can be given information and we have to come up with the equation. So let's look at this. Let's say that we had a system of equation, or we're trying to find the quadratic function in the form of y equals ax squared plus bx plus c, and it goes through these 3 points: negative 2, 7, 1, negative 2, and 2, 3. Means as we graph this parabola, and I don't know if it opens up or down, but it would go through those points: negative 2, 7, 1, negative 2, 2, 3. We want the equation for all the other points. Well, what we do is we're going to set us up a system. This is an x and a y, so we're going to use it to come up with an equation. We're going to take our equation up here, and every place we have an x, we'll put in negative 2. When we have a y, we have a 7. So we get 7 is equal to a times negative 2 squared plus b times negative 2 plus c. Well, what that gives us, negative 2 squared, is 4a minus 2b plus c equals 7. If we did it with the next point, we would have negative 2 is equal to a times 1 squared plus b times 1 plus c. So that would give us a plus b plus c equals negative 2. And taking our last point for our x and our y, we would have 3 is equal to a times 2 squared plus b times 2 plus c. So 2 squared is 4, so that would be 4a plus 2b plus c equals 3. So now we've got our systems of equation, and we can go through and solve them. It doesn't matter which one we pick. A lot of times people will always pick the c's because those all are 1, so you just have to multiply through by a negative. I think I'm going to pick the b's because those are already opposite, so I didn't have to multiply through by a negative. 4a minus 2b plus c equals 7. 4a plus 2b plus c equals 3. Now there is no right or wrong one to pick. So if you're in doubt, just pick 2. Just pick a variable, but once you pick the variable, then stick with it. I'm going to eliminate the b, so no matter what, I'm going to stick with that. Even if a variable drops out or something else happens, I'm still going to stick with the b. So I have 8a, the b's drop out, plus 2c equals 10. Okay, I used my first and last, so I've got to use this middle. I'm going to need to multiply it by 2, and I'm going to use the top one with it. Since that's a positive 2, this will be a negative 2. So 4a minus 2b plus c equals 7. 2a plus 2b plus 2c equals negative 4. Adding these, I get 6a, the b's drop out, plus 3c equals 3. Okay, now I've got two equations and two variables, so I can eliminate one of those. Neither one of them looks just super nice. I'll probably do the c. So my common number would be 6, so I need to multiply this one by 3. And this one I'm going to multiply by negative 2. So I end up with 12a, my c's drop out, equals 24, dividing by 2, a equals, or dividing by 12, a equals 2. Okay, I know what a is, so I can substitute into one of these and find out what c is. So 6 times 2 plus 3c equals 3. 12 plus 3c equals 3. Subtracting 12, be negative 9, dividing by 3, c's negative 3. And then I could go back to one of these. I'm going to do that a plus b plus c equals negative 2. So I've got my a is 2 plus b plus c, which is negative 3, equals negative 2. So I have b minus 1 equals negative 2. Adding 1 to both sides, b equals 2. So my ordered triple is 2, 2, negative 3. B doesn't equal 2. Y'all are probably just yelling at me saying, you need to subtract better, or in this case, subtract better. So I would add 1 here, which would make that negative 1. So B is negative 1. And this is why it's always a good idea to go through and check your answers, because you can make a simple mistake just by being careless, and then your answer's wrong. So that would be our ordered triple. So this is how we go about solving systems with 3 equations and 3 variables.